Hey everyone, so this is the first video of the OWASP top 10, and I'm going to be going over server-side request forgery. Alright, so let me explain exactly what server-side request forgery is as simply as I can. Yeah, so let's pretend we are this user. His name is Tommy, and he makes a request to a website. So this is website, I don't know, pizza.com, right? So he makes a request to the website, and let's say this website's just a vanilla like HTTP CSS website, right? The front end, at least, you know what the client actually sees. So this is HTML. Did I say HTTP? I meant HTML. And depending on what was requested by Tommy, it might have to, oh, let's say it does. It in this case, it always does make a request to the backend client of the website. So this is the backend, and let's in my demo, at least, it's running Flask. However, this could be using PHP. Well, I guess PHP is more so. Let me backtrack. Okay, the website could be using PHP, which is also vulnerable, but I don't exactly know if that's considered backend. But there's Flask. We have like Node with Express and so many things, right? So Flask, just know it's a backend, so it's a server. And in theory, the only thing that can make a request to the backend is the front end. So only this. Oh, I don't know what I did. My Siri, I don't know, man. They're always listening. Anyways, so the front end can only make requests to the backend, and the backend can only accept requests from the front end. I'm not getting into how or why, but just keep that in mind, right? So remember that in the monkey brain. So now let's expand this a little further, right? So this orange square, that's going to be the network environment that is hosting this server. So just to make it simple, I'm going to consider this local host, right? And in this local host environment, we have, I think this is what databases look like a cylinder thing. Database. We could have a, Jesus, make a square, rectangle. We could have another site that's gonna, this. Let's say this is a dev site, right? Where you can, I don't know, do devy things, right? So these two instances, the database, the dev site, it's only accessible in that local host environment, which, to bring the whole picture, little boy Tommy over here can't access the database because it just doesn't work like that. Only the backend boy or even clients inside this network, so like other users, hosts, machines, whatever, that are in this environment can talk to the database and dev site, assuming there's no other things in place like passwords, or you get the idea, right? So you have to be inside this to request this. This is where server-side request forgery comes in, right? So how this works is little boy Tommy, right? He put his little script kitty hat on. You know what? I'm just for lols. Script titty cat hat. Oh my god, I can't talk. Hats on, and let's say we have this endpoint, which I think in my example is admin, right? So we have admin. He makes a request to /admin. But backend server over here says, nah, you can't get in. You can only get in if your IP address is 127.0.0.1. So he says, nah, you can't get in. So little Tommy thinks, okay, what if I then exploit another endpoint fetch and pass it HTTP local host. There's a port in my example. We could ignore that. Admin, right? So then what happens here is how the fetch endpoint works in my demo, which I'm going to go through in a minute or two, is it uses Python requests module and makes a request on this server's behalf, right? So what happens now is this URL gets passed to the backend server. The backend server then does a request. It uses the request module, remember, with that URL, this one. So in that case, it is doing a local host lookup. So it's going to let you then view the /admin. So let me show you that demo real quick. Alright, so here I have my Flask image running. This is using Docker and Flask. And let's take a quick look under the hood, right? So we have two endpoints. We have our fetch and our admin. As we could quickly see, our admin's only accessible under the IP 127.0.0.1. And we'll get an access forbidden if we're not, right? And here's pretty much where the SSRF vulnerability lies. It's under the request. So all this does is, in that post request, there's in the fetch endpoint there's a form, and whatever URL is passed in that form, then there's a request. So let's see how we can get to admin. So if you go to admin right off the bat, we get an access forbidden. And if we, let's go to Google, we know this works. But what if we accessed the site directly? So instead of making a request to Google, what if we did localhost, the same port, and let's try admin. Okay. This is a bug on my end, but we did access admin because if we go back to the code real quick, I'll explain my bug right now. What it did was it checked if my address is 127.0.0.1, and it said yes, it is. Why and how do I know that? Because it went to the else statement, and this is where the bug lies, where it gets the arguments CMD. It then executes that command onto the OS and returns it to the content. So the reason why I know there's a bug in my code is because it said it got class none type. Hence, I didn't pass an argument CMD. So since we know that it's making the request for us, if we did admin past CMD, I think it's what, ls, we can view the files. So we now turn this from server-side request forgery to remote code execution to... I just wanted to quickly note that in this example that I made, we did get remote code execution, but I kind of just simplified it a lot. Because it is possible that we could get access to some sort of admin or developer site or environment through SSRF. However, there could be vulnerabilities or some additional access on those platforms that can give us remote code execution and the like. I mean, remote code execution is pretty bad as it is, but at this point we can read files on the server or on the server in my Docker image. We could even access our own site. So I have my mic. I'm trying to view. Okay, you have my mic and stuff right here, so I'm trying to go around it. Anyways, so I'm running a Python locally. You know what? Let me do this. So let me change directories to. I didn't test this, so hopefully this works. But let me go to my downloads. Yeah, that's fine. So what I'm going to be doing here is I want to run a server locally, then I'm going to be using ngrok to then make it publicly so my Docker instance can access it. So let's just name it that. Okay. So I added a file onto my downloads folder. I'm going to be running Python again to run it locally. Server, was I doing port 80? Yes, port 80. And that's going. So let me copy my ngrok. And then let's do the file that I added. So what I'm trying to do here is not only request my website, which should most definitely work, which I'll get to why that might be bad, but I'm going to try to download a file. Though, now thinking about it, I am using the request module, and that kind of just makes a request. I don't think that's going to download the file, but let's check it out. Okay, so, Jesus. Where is... There it is. Okay, cool. So we see that we get a request for the file, and we also get a request here. So it obviously wasn't able to download. Yeah, so it didn't download any files. That's just because we're using the request module. However, it did access my website. Now, the reason why that might be bad is since we're having the backend server make the request for us, the actual computer, if we were using some sort of, I forget the word, I guess proxy for lack of a better word right now, in between the backend and our front end, then we could potentially get the real IP of the backend server as opposed to the proxy. So let me explain that a little. Let me. I like visuals. Monkey brains like visuals. Okay, so we have Tommy here, and over here we have client, which is our website that we can access, and we have backend, right? So say in this example that I'm talking about, we have a proxy. So that could be Cloudflare. Is that what it's called? Cloudflare. I don't know what it's. How do you spell it? But so client makes a request, it goes through that proxy, and then the proxy goes to the backend. But what we see back is the proxy IP. However, since the backend is making the request for us, we could potentially see the backend IP, which could be bad for. It's beyond this video. So that's pretty much server-side request forgery. So we can access internal infrastructure. So if, for example, we had a database, since in this case I made it so we have remote code execution. If there was, we could do a ping scan. We could potentially access databases and other servers, how I did in my example. We could view files, easily get a reverse shell. So you're probably thinking, well, how can I protect my code from this? So there's a few ways in doing that. One of the ways is using a whitelist and blacklist. So for example, in this fetch endpoint, what we could do is potentially make a blacklist and say if the user input contains like file, I don't think request module can do file, but let's just say it can do file HTTP, or no, I'm sorry. For it to work in this context, we could probably have it if it includes localhost or 127.0.0 whatever, then just kill the connection, right? This would most definitely block your average Tommy script kiddie, but there are potentially bypasses to this, but it is a start. We could also do a whitelist approach to this. So instead of just allowing the user to input whatever they want, we could do some type of drop down and then have a whitelist in here to make sure it's part of that drop down. Again, potentially bypasses depending on the server. I think I can't remember what it's called. This is beyond the video again, but in case you're curious. So this right here is one request, right? So if you were to go to burp and capture this request, you could potentially stack another request. And long story short, technical talk, it does the other requests and like, anyways, there are potentially bypasses to that. Something to keep in mind. Potentially even use a third-party module to handle this for you. They probably considered all the edge cases, but again, do your research. So I hope you enjoyed this SSRF video. This kind of high level, but there's some details that I probably could have elaborated more in this video. If you want that, let me know.